Okay, so here's our next lesson. This one's focusing on surface area and volume. So in the last lessons, we looked at this k factor, this scale factor k, and that's just the length of a similar shape divided by the length of the original shape. We also saw area, which is the area of the similar shape divided by the area of the original shape, but it's equivalent to k squared. So for volume, that's what we're looking at today. Volume of two similar shapes is the volume of a similar shape divided by the original shape. That gives us our k cubed value. So we're just going to look at this question to start with. It's a small cube and a big cube. And we're trying to figure out what is the relationship between these two things. So first, what we can do is we can solve for our k scale factor. So k is going to be, if we compare the two, I'm going to say the small one is our original object, and 12s are the bigger ones are similar. So k is going to be equal to our similar object, so we're going to say 12 centimeters. We're going to divide that by 4 centimeters. So we're comparing two of the similar lengths. And so 12 divided by 4, we get a scale factor of 3. Okay, so that's what we did in the first lesson. K is equal to 3. The question is, what is k squared? So we can actually go ahead and solve it right now, but we're going to basically do it twice. We're actually going to solve for the surface area and solve for the volumes, and so that it comes out to be the same value. So if I look at k, if I actually just take this value and square k, so k is 3. If I square that 3 squared is 9. So that is our area scale factor. So basically what this tells us is that the length was 3 times longer, but the area is going to be 9 times as much. So there's going to be 9 times as much material on this bigger cube compared to the other one. If I look at k cubed, if I say k is 3, 3 to the power of 3. So k cubed is 3 times 3 times 3. So 3 times 3 is 9, times 3 we get 27. So this is our volume scale factor. So what that means is that if this original box could hold so much amount of liquid, this bigger one can hold 27 times more liquid, or the volume of stuff. So let's go ahead and actually solve for the area of each one. So surface area for a cube, well, for one square, it's length times width, right? Length times width. But how many faces? There's 1, 2, 3, 4, 5. There's 6 faces. So if I can find the area of one square and times by 6, that will give us the surface area of a cube. So I say, okay, 4 centimeters multiplied by 4 centimeters. Right, so that is the area of one face. So 4 times 4 is going to be 16. And then I have 6 of those. So I'm going to multiply that by 6. We get a total of 96. Sorry, times 6. So we get a total of 96 centimeters squared. And by writing our units in centimeters squared, it's telling us it is area. Look at the other one. So this is the surface area of the small one. Let's look at the surface area of the big shape. That's going to come out to be 12 centimeters multiplied by 12 centimeters. And we're going to times that by 6 as well. There's two ways we can solve for this. I can solve for the other one separately like I am right now. So you go 12 times 12 times 6. You get 864 centimeters squared. But there's a different way. If I know 1, if I then took this and multiplied it by my area scale factor, 96 centimeters squared, if I multiply that by k squared, in this case k squared is 9, guess what it comes out to be? 96 multiplied by 9. It also equals 864 centimeters squared. For like a volume now, volume is just going to be length times width times height. So in this case, it's going to be 4 centimeters multiplied by 4 centimeters multiplied by 4 centimeters. So 4 times 4 is 16. And multiply that by 4 again, we get 64 centimeters cubed. Right? Cube tells us it is the volume. Now if I look at the other ones, that's the small. The big one is going to be length times width times height. But it's going to be 12 centimeters times 12 centimeters times 12 centimeters. So 12 times 12 is 144. multiply by that 12 again, we get 1728 centimeters cubed. But again, instead of having to calculate the whole new one separately, I could have taken that 64 centimeters cubed. I could have multiplied it by my k cubed factor. And k cubed we found to be 27. So we're going to say 64 times 27. Guess what? 1728 centimeters cubed. It's the same as what we found. So the whole point of this whole unit that we're doing right now is basically to recognize that, like, basically link together this whole k scale factor thing with the actual individual calculations of area and volume. And another way to prove that the k cubed thing is true, if I take that 1728 divided by 64, guess what? That equals 27. If I take that 864 divided by 96, that's equal to 9. So again, this, we are trying to just basically link, combine our understandings. Basically, do we understand what this k cubed means? What do we understand what this k squared means? Again, if we understand this, then you've got the whole meaning for this topic that we're currently doing.